This transistor, the technology we're talking about at the 7 angstrom, provides 50% better performance, or it will save 70% more power when it does the computing. This is a massive improvement that our industry hasn't seen for a long time.
All that and more on today's Mixture of Experts. I'm Tim Hwang, and welcome to Mixture of Experts. Each week, MOE brings together a group of the researchers, builders, and thinkers working in artificial intelligence to walk you through the week's news. On this week's episode, we've got Abraham Daniels, Senior Technical Product Manager for Granite, Martin Keene, Master Inventor, and Gabe Goodhart, Chief Architect, AI Open Innovation. We're going to talk a little bit about A24's partnership with Google DeepMind this week. We'll talk a little bit about the phenomenon of tokenminning. And we're going to talk a little bit about these new models that have hit the scene, Sakana Fugu and GLM-5.2. But first, we've got a special segment with Sascha Brodsky interviewing Huiming Bu, VP of Silicon Technology Research and Development, on the sub-1nm chip.
Hi, Huiming. Thanks so much for joining.
Hi, Sascha. Thank you for having me.
So before we get into the technology, help us understand why this announcement matters. For someone who doesn't follow semiconductors every day, why is breaking the 1 nanometer barrier such a significant moment?
So let's start with, semiconductor essentially are the chips, I would say, charge every single thing we are doing in our modern life when it comes to devices. So if you look at that angle, and I realize our industry has been relying on semiconductor for transistor scaling for the last 60 plus years. What does it mean? A MOSFET actually was invented in 1959. And since its introduction, we have been making the transistor smaller and smaller, more powerful, and it consumes less energy. So far, we have been successful for most of the time, but in the recent years, we have been hitting some of the very, very, very difficult challenges. Takes billions of dollars to invest, provide solutions. And we are at a point now looking back at the 60 plus years, we have been doing transistor scaling in the X direction and a Y direction, essentially in a two-dimensional world, which we call it defined by lithography scaling. Today, this sub-1 nanometer announcement is for the first time in the history of the semiconductor industry, we are stacking the device in the vertical direction, Z direction, which is a direction our industry has not explored in the past 60 plus years. And now we are at the end of the shrinking in XY two-dimensional. The third dimension of Z provides tremendous opportunity for the future of scaling.
So interesting. Now, for years, we've heard that Moore's law was slowing down, that the industry was running into the physical limits of silicon. What challenges were you trying to solve with this technology?
When I joined the company in 2005, we faced a major challenge in transistor. So what happened back then is that when we trying to make the transistor smaller, and one very, very important material in the transistor is a dielectric. We call it gate dielectric. At that point of time, it was silicon dioxide. It started to leak like crazy when you make it thinner. And we provided the solution. The solution came with a new materials. We introduced high-K metal gate to replace the silicon dioxide and the polysilicon at that point of time was the gate material for a traditional transistor. And we suppressed the gate leakage. And the scaling, you call it Moore's law, continued. Another example is only a few years later, what happened there is for the first 45-ish years of the transistor scaling, we have been using a planar device, as I mentioned, in 2D. That is called planar device. And when you make a device smaller, the short channel effect shows up, which means there's another leakage starts to show up. Electrons start to flow in the channel when the device is even turned off. So at that point of time, our engineers introduced FinFET. I can show you a cross-section actually about how a FinFET looks like. This is a gate. This one is a fin, similar to the fin of a fish. That's why it's called a FinFET. The gate wrapped around this fin on three sides, left, top, and the right side. So it's called a tri-gate FinFET device. And this device has much better gate control, hence it suppresses the leakage in the channel. These are a couple of examples of the key challenges, one on the material side and one on the device architecture side we faced, I would say at this point, more than 10 years ago.
IBM is calling this the world's first sub-nanometer chip technology. What does sub-1 nanometer actually mean today? Is that literally about the transistor size, or is it shorthand for a new generation of manufacturing?
Today, the technology node name is no longer directly correlated to any physical dimensions in the real device. It actually becomes a node name quite a few years ago. And it's you can consider it's just a name to show the technology keeps evolving. So after 2 nanometer, today best available technology in manufacturing is 2 nanometer. After 2 nanometer, there's 1.4 nanometer. After 1.4 nanometer, there's 1 nanometer. After 1 nanometer, there's 7-astron technology. But one thing you probably have realized is if you divide the number, the new number versus the old one, generally speaking, the ratio is 0.7. That is called a scaling ratio. That is a real number. So we have kept a scaling ratio of 0.7 because 0.7 times 0.7 is essentially 0.49. And 0.49 means your area of scaling, or in other words, your density keeps increasing. That is a scaling factor.
One of the phrases that stands out in this announcement is nanostack. What actually is nanostack, and how is it different from the chip architectures that are being used today?
Yes, great question. Here is the cross-section of the nanostack. I'm going to let you just look at it for a few seconds. I explain what's actually in front of you. So let's look at this direction. If you look at it, you're going to realize there are 2 nanosheets here. This is 1 nanosheet. Here is another one. They are not on the same plane. One is on top of the other, but not exactly right on top of each other. This is a transistor design. We call it vertically stacked and also staggered. So think about 2 transistors. You stack them, but you also stagger them, both in vertical direction. That's why we're saying nanostack is a device enabling the transistor stacking or scaling in the Z direction, in the vertical direction. The beauty of this device is the following. One is these 2 devices, or 2 wafers, top wafer, bottom wafer, top device, bottom device, they are actually not monolithically defined by a litho etch process. It is actually using a thin dielectric to bond them. Because of the thin dielectric bonding process, these 2 devices can be optimized independently, which means you can use the best material you can think about for the bottom device, best material you can think about for the top device, and they can be optimized for performance independently. The other unique nature, if you look at this device, is because they are stacked and staggered, both the front side of this top device and the back side of this top device, front side of the bottom device, back side of the bottom device can be contacted with your signal line and power line directly. That is itself provides tremendous density scaling benefit with this nanostack structure.
This chip packs nearly 100 billion transistors into something about the size of a fingernail. At that scale, what are the biggest engineering challenges? Are you fighting heat, quantum effects, manufacturing precision, or all of the above?
So let's do it one by one. I explained each of this, the thickness of each of the sheet is about a 5 nanometer. You can consider there's some process margin with it, whether it's 5.5 or 4.5. So let's talk about a quantum confinement effect using the 4.5 nanometer chip. Do we observe quantum confinement effect in this device? The most pronounced observation when you observe quantum confinement effect is threshold voltage variation. So far, we have not observed the quantum confinement effect in threshold voltage variation for the thickness down to 4 nanometer. So we are still operating in a safe zone away from the quantum confinement. The second one you asked is heat effect. Yes, heat is a very, very important factor in this device. The way to think about it is these devices that are vertically stacked, you have less heat dissipation paths. So you do have to have innovative way to provide thermal conduction, just like how you do the electroconduction. To do the same thing to conduct thermal better in this device. And we have engineering work to provide that solution as well.
AI is driving unprecedented demand for computing power. How much of this breakthrough was motivated by what you're seeing from generative AI and increasingly demanding AI workloads?
Yes, that is the fundamental reason we are enabling this device. I spent quite some time to talk about why you would observe density benefit, but let me talk about the power performance benefit. With this structure, compared to 2 nanometer we announced in 2021. By the way, as I mentioned today, the best, most powerful available chip is manufactured with 2 nanometer. Consider that is the best, world's best chip. Compared to that one, this transistor, the technology we're talking about at 7 angstrom, provides 50% better performance, or it will save 70% more power when it does the computing. This is a massive improvement that our industry hasn't seen for a long time. That is why we are so excited when it comes to high-performance computing, especially for AI computing. Another thing I want to mention, maybe share with this audience, is the other benefit of this transistor architecture provides when it comes to AI computing is the very significant SRAM size scaling. The nanostack provides 40% SRAM area scaling compared to the 2 nanometer. That is a significant step forward in SRAM scaling that our designers haven't seen for more than a decade. And all the AI computing requires memory. And SRAM is an embedded memory solution with your computing unit. This level of the SRAM density scaling enabled by nanostack will truly help AI computing to be a lot more efficient moving forward.
So finally, if we're sitting here 10 years from now, looking back on today's announcement, what do you hope people will say this breakthrough made possible?
I would say this nanostack architecture innovation is in the first time after 60 plus years in semiconductor industry has truly made our computing logic device go from a 2D to 3D in its design for the first time. That has opened a completely new dimension for the future of scaling, which at least we can see 10 to 15 years of technology roadmap ahead of us.
Thanks so much for joining, Huiming. This has been a wonderful opportunity, and I appreciate you being here.
Thank you for having me.
First, I really want to talk about these two new models that have hit the scene and have been at least eating my social media feeds completely over the last week or two. One of them is a new model, a coding model from Z.ai, a Chinese lab called GLM-5.2. And the other one is a model by a Japanese lab called Sakana called Fugu. It's sort of an agentic model. And we'll talk about both of them. You know, I think the first one I wanted to talk about was Sakana, though, because we had never, ever talked about them. They were not on my radar at all. This is the first time I had heard about them. And the numbers for the Fugu model are really shocking, right? They have these charts where it's like, oh, you know about Mythos, that model that everybody's been talking about for a really long time? Well, we're already there and actually above in some respects. I guess, Martin, maybe I'll bring you in. what's going on here? I thought Anthropic and OpenAI were, so far ahead, so on the cutting edge that no one was ever going to catch up. And as yet, I guess, I don't know, maybe I just haven't been watching the Japanese AI scene, but the idea that a model could come out and have these kinds of metrics, it's a little bit shocking, isn't it?
Remember when Claude's Fable was like the best of the best? That was like last week.
Yeah.
Now we have something else from apparently out of back field. So yeah, it's absolutely crazy. And it does particularly well in coding tasks. So it's doing very well on live code benchmarks, things like that. Which, already we could say the big frontier model labs, they are absolutely laser focused on this. It's not like they've picked a metric that nobody was really looking at and then suddenly maxing on that. So yeah, this is really impressive to see. And just kind of the whole Sakana AI platform is really interesting because this is a multi-orchestration model. So you send your request in and it can go to one of multiple models. And in fact, the models can change at any point. So if a model goes away or a better model comes along, it can kind of slot in there. And it is interesting to think about going forward, are we going to see more multi-orchestration kind of harnesses where we just go to multiple platforms, multiple models, and that changes constantly? Or are we going to continue to see this focus where we all get super excited about this new model that's come out, and we're suddenly sending all of our workloads to that new model for a couple of weeks until the next one comes out? And I'm really interested to see where that goes, because this whole idea of multi-agent orchestration and a platform means that if there's one model that's really good at a particular task and there's another model that's really good at another, that they can diverge, and it will be interesting to see where that goes.
Gabe, do you buy the numbers here? I mean, I don't know. I look at these stats and I don't know. They're just sort of so unbelievable in a certain respect. My immediate instinct is, oh, is this metrics cherry picking? Like, should we buy kind of what they're putting forwards, or I guess like Martin. I mean, Martin, sounds like you buy it. This really is the real deal. I don't know, Gabe, are you on a similar page?
I think the numbers are great. It's really, really cool to see success with this architecture. But I think we're doing it a disservice by calling it a model, because fundamentally that's not the innovation here. Like, yes, there is a single novel model here that is the router, but everything else is all the existing frontier labs. It's just passed through. So what they are doing is not actually creating a net new model that can achieve these benchmarks. Like you were alluding to, Martin, they are figuring out how to get the best results out of the models that already exist and stitch those together in a meaningful way to solve problems. And many folks on this panel and in other discussions have been saying for a long time that there's a lot of green field in this orchestration space. But I think in some ways the fact that every endpoint looks like a list of JSON objects with a role and a content field, and you could put whatever you want behind that API. And in this case, what they are putting behind that API is a carefully routed, orchestrated, multi-model ecosystem. So calling that a model endpoint is not very accurate. And the other piece of this that is interesting is that one of the claims they made is that this gives an enterprise resilience to model fluctuations and model changes. And that's true. But on the flip side, it also means that your quality could change wildly depending on which models it actually gets routed to behind the scenes and how well the routing performs for a given task. So you're essentially trading the fact that you'll always get some answer for the fact that you really can't predict what answer you're going to get. You get even more non-determinism because now you're not just dealing with the non-determinism of the specific model, but you're dealing with the additional non-determinism of which model your request is even going to land on, or which collection of models are going to service the subcomponents of your request. So it's a wide open field. So to your question about, do I believe the benchmarks? Yes, I believe that at their perfectly routed settings, they are actually able to achieve better than any of the individual models can achieve on their own. Do I believe that that's going to be the floor of quality? No, I don't. So I think it's probably just got a much wider aperture for quality than the other ones because it's got a much wider set of quality models behind it.
Yeah, it's like those robotic demos where the robot does it like perfectly. And you're like, this is the trial 1 of 100. And the other ones are the robot like failing to be able to open a door, just like falling over and not being
But
able to do
usually it's not
anything.
trial 1. Usually it's trial like 74 out of 100.
Exactly. That's just right. But as yet, I mean, so all these points are granted. Abraham, I actually wonder whether or not we worry about the wrong thing with AI. So obviously the big stress around Fable 5, about Mythos has been, say, the security aspects of all this, right? That the models are now so good that it poses this huge cybersecurity risk. And I think, granted, right, what we're seeing here is an assemblage of models, not a model in of itself. But it kind of says that maybe like is the cat out of the bag already, right? Like if we feel like Mythos is a model that's so dangerous that we need to do Project Glasswing or whatever, isn't the fact that you can kind of stitch together a bunch of models and get to the same result mean that we're trying to control like the wrong thing? Or in the very least, we can already get the kind of scary things we're worried about with sort of not commodity parts, but certainly like off the shelf parts. What do you think about that?
I mean, I've never thought of it that way, to be honest. It is interesting that you bring that up. The way I kind of saw this from Sakana's point of view was it kind of pitches frontier capability without the risk of export controls, to be honest, or government intervention without any sort of control over the actual user of the model. So I kind of saw this as like maybe not a direct shot, but like, where at times, US frontier models are getting restricted. Enabling orchestration gives you a little bit of a protection around what you can and cannot use, given you could build the same capability in the aggregate, kind of to your point. I was really going to echo a lot of what Gabe said in this regard. Like, I don't see this as a fundamental jump in terms of a new model. I think we're gearing towards orchestration as the product as opposed to the actual model as the product, really, with Sakana. And I think it does a really good job of kind of providing a very simple user experience. Like the idea that it's all behind an API is great because the user doesn't have to care about the orchestration or know what model is actually getting hit with respect to a particular, query. So I thought that was a really good direction. And I think that's really where things are going to start going in terms of being able to build out frontier capabilities as opposed to frontier models, and really focusing on that aspect of how do you actually get the most out of a model or a system of models or orchestration of models for the user.
And just to jump on that, something that I know you focus a lot on, Abraham, is essentially this virtual model idea and what you can do behind a virtual model endpoint to get the most out of a collection of models or even an individual model being orchestrated carefully. So the Malaya project out of IBM is a great example of this. And it's not aiming necessarily at pushing that frontier. So one thing I'm really excited about is taking this same concept of a virtual model endpoint and bringing it to the small scale. So maybe it's not going to push Mythos capabilities, but if it could push Sonnet capabilities and run on your smartphone or run on your commodity laptop, that might actually be the real innovation where we can get acceptable quality in a much like order of magnitude smaller footprint than we would based on a single model just based on the weights. So I'm really excited for this overall trend of orchestrated virtual models. Chasing Mythos and Fable is a lofty goal, and it definitely makes headlines, and it's really cool. But I think the real impact is going to be at horizontal spread of smaller models with great capabilities.
Let's maybe take a few minutes to talk a little bit about Z.ai and the new GLM-5.2. Gabe, you just commented, but maybe we'll stay on you. With these coding models, I'm not doing coding day in, day out. I don't know if you've played with the model yet, but curious about kind of like just your taste test. I think we can look at the metrics, but really as someone who's doing this day in, day out, I feel like you've got probably a better feel for like, is there a good, terroir for the model? Is there a good kind of like, what's the taste of this one? Do you like it? Yeah.
Yeah. So, I guess in fairness, I haven't tasted this one. I've read about other people's tasting experiences, but I haven't tasted it myself.
Good
and a lot of that,
notes, yeah.
Exactly. Yep. Yeah. I've got the flavor profile, but no, I think, staying on that point for a minute, one of the things that's interesting is that with these open weights models pushing size frontiers that rival the frontier labs. What we're really starting to hit also is usability gates, right? So I do the vast majority of my coding in a professional capacity because when I'm not doing that, I'm chasing children around, and there's not a lot of time for writing code while I'm chasing children. And given that, I'm basically gated behind what is acceptable to do in my professional capacity. So I'm not able to actually pull this model locally because it's enormous. And, I also am not allowed to send any of my professional work to GLM. That's just an interesting aside that, yes, this is really cool because it's an open weights model, but the size is still a physical limitation for tinkerers like myself that want to just sort of unbox it and play with it. That said, it still is the story we've been telling over and over again over the past couple of years is that we get major leaps in quality out of the proprietary labs, and then open models, often out of China, catch up in a meaningful way. And the interesting thing that I think is that it's not just one Chinese lab that's doing this. This wasn't another round of DeepSeek or another round of Quen. This is, another lab that, yes, has been making great models for a while, but hasn't been the one grabbing the headlines. And now they've kind of surged ahead by a nose, and we'll see who wins the race type of thing. But, I think it's awesome to see that these capabilities keep staying on the frontier. And I also think it's really cool that the innovations at the model architecture level are continuing to be published in the open. So that was one piece that I looked into with this, is how they, which architectural widgets are they borrowing from which other models. It's highly inspired by the latest DeepSeek architecture, but it's able to actually bring speed and quality at an extremely long context length to an extremely large model. And that's awesome. So I love seeing those quality, pieces pushed. And again, true to myself, I like things that I can hold in my hands. I hope this same architecture gets released in a much smaller footprint, say approximately 100 billion parameters that fits on a DGX Spark, so then I can play with it myself.
Martin, and I actually want to pick up on that point that Gabe is making. It's kind of interesting. It feels like out of the kind of Chinese market for models, it seems like there's a new player, every few months, right? Where you're like, oh, wow, Z.ai, like they're new. Is not just like another DeepSeek thing. Versus, I think it feels like in the US market, we've gotten very much into the mode of like, okay, OpenAI is doing one. Now Anthropic's doing one. OpenAI is doing one. But there's not so much like we're blindsided by a new lab that comes out with a model that's like, kind of capturing the headlines. And I guess kind of the question is like, do you feel like the US market is like almost insufficiently competitive? Like, you only have these two labs now that are doing like a lot of the model work, versus where in the US or in China, you feel like there's always a new lab kind of popping up.
Well, I was not even aware of GLM models at all until this one, 5.2, came out. So to me, this is just something out of left field. But of course, it's not. I mean, this 5.2 tells you something. This is not their first rodeo. So yeah, I mean, it is an interesting point, Tim, that there are so much innovation coming out of a country that has been traditionally restricted with its compute capacity as well for being able to build these models. But it is also interesting the direction that this has gone, because it seemed like the direction initially we were going is you have big frontier models from the big labs, the big three that we were always talking about. And then you have these open weights models, which are maybe 9 months behind everything, but they're also a bit smaller. I can run them maybe on my laptop or a dedicated GPU. Well, that is not really the case here. This model, this GLM 5.2 is about the same size as Claude Sonnet 4.6. It's enormous. So these are not models that you're just going to kind of take and run in your basement anymore. These are models that need to be deployed somewhere. And to go to Gabe's point, like if I want to access this model now, firstly, it needs to be somewhere that I can get it because I can't install it myself. And now we have all sorts of governance issues as to, well, am I allowed to access it, and who is hosting it for me, and what sort of workloads can I send to it, and can I trust who's doing the hosting, all that sort of stuff as well. But also, it is great to see that this research is now, it's published, it's available for everybody to see. It just speeds up the whole development market for all of this. I've been following along with some of the people who have been able to use this model, and it does seem that in coding tasks in particular, it's doing a great job. with a few little caveats. Like apparently it had a very large Mandarin training data set. So it will just like splurt out random Mandarin phrases, apparently, even when you're talking to it in English. So you never know when that's coming along. But yeah, just kind of fascinating to see how these things are developing.
Well, I'm going to move us on to our next topic today. Really interesting headline. We've been kind of having a subplot of this, as we get into the summer here at MOE, which is, I think, the kind of relationship between the, emerging AI industry and, filmmaking, art, entertainment. And there was a big partnership that was announced between Google DeepMind and A24, which is the studio behind movies like The Backrooms and Marty Supreme, and kind of known as, in some ways, like a kind of prestige sort of film studio. And, the interesting thing is basically what it sounds like is DeepMind's going to team up with A24 and they're going to build new AI tools for filmmakers to use. And so this is a little bit different from, oh, hey, they're going to just start producing AI movies. It's a little bit thinking a little about the back end kind of toolkit. And Abraham, maybe a question for you. I don't think it's unfair to say that like the relationship between entertainment and the AI industry has been pretty fraught. I would say, a lot of people do not like what the AI companies have been doing. And one way of viewing this partnership is maybe a kind of like, olive branch peace deal to say, well, look, we're going to work with you to develop tools to do filmmaking. We're not going to just try to do, AI generated film or whatever. I guess question for you, Abraham, is like, do you think this like changes the narrative? Like, is this the beginning of what a beautiful relationship might look like, I think, between the AI industry and sort of filmmaking and the arts? Or is this just not going to be, this is just a blip in what is already a negative relationship? It might be getting more negative over time.
I think it's a great olive branch. Two, I think it's the beginnings of a better relationship, maybe not a beautiful relationship. So the way it was framed out, I think, was just really strategic in terms of building tools with artists and the idea of trying at least as best as possible to preserve creative control. And I know that the first prototype for this was kind of the storyboarding tool, which is really precursor to the movie. So if anything, it adds a lot of kind of value to expediting that process. I read earlier too that, Martin Scorsese, arguably one of the most, recognized directors, also partnered with an AI firm to build out some AI storyboarding tools. So I think you're starting to see a little bit more appetite from the industry in terms of AI tools. Truthfully, I kind of see this as like, when CGI and 3D animation, 3D kind of came onto the scene, and, a lot of individuals on the animation side of things or on these, set design were kind of ousted with these respected technologies. And now it's kind of moving upstream to actors and actresses. I think it's inevitable, but I do applaud A24 in terms of getting in front of this and trying to kind of frame this more as an additive as opposed to a replacement. Truthfully, let's just see how it goes moving forward. I don't really have a position in terms of how this is going to land. But, with more and more artists recognizing that this is going to be an aspect of it and potentially protecting your copyright or IP, whether your image, I know Taylor Swift has done that in certain cases. So I think it's just going to be something that we continue to see in terms of trying to protect your brand or really your ability to make money in this industry. But to your initial question, I do think this is the beginning of trying to mend or at least build a bridge between the two sides.
Gabe, why do you think A24 is doing this? They're obviously a very well-regarded studio on the scene. This using this technology, partnering up with big bad technology, is maybe a little bit fraught for them. What's their angle? What do you think they get out of something like this?
I guess I have a cynical view and an optimist view on this. So the cynical view is that a studio like A24 has the credibility to spend, and they can see where the ball is going to go one way or the other. It's somebody is going to do this, so they'd like to be the ones doing it, right? They'd like to set the playing field for everybody else. So that's kind of my cynical take, that it's more of a getting out in front of the narrative play. But my optimist take is that, this is actually akin to I'm going to make the analogy to, again, something I know and love, which is coding agents. I think, you think about the early attempts at AI in the film industry, they're very akin to vibe coding. They're basically single shot this thing like, I want a video that looks like blah. Give me one of those. Cool. The end. And now, just like in coding, we're recognizing that vibe coding is wonderful for prototyping and for demonstration of the possible, and pretty terrible for actual professional usage. I imagine that this is going to look a whole lot like that within the context of the film industry. So again, just like Abe said, I think the framing it as tools rather than models is intentional and important, because as we think about, coding agents in the hands of developers, we think about the nuanced usage patterns, how you map these tools to the existing workflows of developers. I hope that DeepMind and A24 will do the same thing in the context of movie production. And so storyboarding is a great example. That's akin to project planning in software. And that's a place that you can absolutely get boosted without having to necessarily replace the actual quality and architectural integrity of a piece of software. I hope the same thing gets held true in the movie industry, so that we have high quality stories coming out. They're just coming out better with the help of the new tools.
I get that. Martin, do you want to, so they haven't talked a little bit more about, to Gabe's point, like haven't talked too much about like the precise tools they're building. But I think it might be fun to do a little bit of like pie in the sky. I don't know if you have kind of dreams about what these tools might look like, but it just seems like is a lot to be done outside of the completely kind of naive, like, I need a movie about blah, and like the movie comes out. There are a lot of kind of really interesting tools here, but curious if there's anything that you have in mind where you're like, oh, it'd be really cool if they built X, Y, Z, or I wonder if this might be what the future of it looks like, if you want to kind of dream a little bit about where this all might go.
Tim, I absolutely have some dreams about this. To me, this deal is absolutely wild, because DeepMind are going to be creating tools that will help A24 create their movies, right? So how much are A24 paying Google DeepMind for them to develop the tools? Oh, they're not paying anything. They're getting paid $75 million. Google are paying the studio to use Google's tools. That's absolutely wild. And of course, why are they doing that? Well, because they need to understand the use cases of what is it they're doing in terms of the storyboarding and the production and the animations and the all of it. Whereas these labs already know how to do coding. That's what they do. So they don't really need to be doing these big deals with somebody to learn how to code, but they do need to learn how a movie is made. And that is so valuable to them that they're willing to spend tens of millions of dollars doing it. So you mentioned dreams, Tim. My dream. On the side, I like to brew like fancy, pretentious coffee, and I have all these coffee machines that brew the coffee, and some of them have started to have AI features in there. So this, just in case like Demis Hassabis is listening to this, I just want to put out an open call. If they would like to learn how to brew fancy coffee and how that DeepMind could help with that, I would be more than willing to offer my coffee experience for much less than $75 million and teach the model how to do that.
Well, this is great. And a lot more to come. And I think, Martin, I buy your point that like we will see these sort of interesting collaborations. Entertainment, of course, is the most prominent one. But I wouldn't be surprised if you find like, oh, well, we're going to team up with a prominent coffee maker to build tools for this, right? We're going to team up with a prominent, every domain, right? I think like is amenable to this. My friend, actually reminded me that back in the, I think 80s or 90s, there was actually a rice cooker that was sold with one feature being that it contained a neural net. And it was like a really, really old school perceptron that was used to just measure kind of like moisture in the rice cooker. And it was using it to like kind of improve the technology. And so, I think we're going to see all sorts of partnerships like this emerge in the future. All right, well, let's move to the final topic of the day. This is kind of more of a culture piece. Needless to say, for a period of time, I think corporate America was very gung-ho about people using AI more. And like so many things, what you measure is what you get. And so a lot of these companies were measuring their success at adopting AI based on how many tokens were consumed. Because, of course, the more tokens that are consumed, the more people in a company are using AI. The problem with that, of course, is that tokens are expensive, really expensive, and sometimes colossally expensive. And so there's been a number of pieces. One of them that we caught our eye was a piece by Eli Tan at the New York Times called "Tech Workers Maxed Out Their AI Use. Now They're Trying to Minimize It." And specifically talking about the phenomenon of token minning. Now we've gone a little bit too far in terms of token maxing. The idea is, how do you get done what you need to do with the least number of tokens? Abraham, I guess question for you is, like, how widespread is this phenomenon? Do you feel like in general enterprises are starting to be like, whoa, we've just spent way too much on tokens. Everybody's got to be on this like much more fixed diet of tokens now. And is that going to be the norm in the future? Are people going to just start tightening their belts when it comes to this?
Yeah, I think you've seen headlines, whether it's Uber or Microsoft or other enterprises, either restricting or limiting API or access to Claude models just because, within 3 or 4 months, they've already swallowed up their entire yearly budget for the usage. So I think you're definitely going to see it. And to your point, there is, the fundamental shift from token maxing to token minting. I think the narrative shifting away from, more tokens means more productivity and more so token economics. Like, how do you get the best result for the unit economics of a single token? And then I think that kind of plays into our earlier, conversation about orchestration of models to define, how do we get the best output independent of whatever model was used using some type of, orchestration layer. So in short, yeah, I think this is kind of the direction forward. Inferencing costs exponentially more to organizations want above the burst than model training. So there has to be a better way of actually, building a business case around this. And for the user experience, I just think it's something that we're already starting to see.
It seems like the problem here is that we have a really hard time measuring like what the business value per token is. Like, we've been maxing because there was an assumption that the value was greater than the cost of every token. Now we're minning because we actually believe the value is less than. But at the end of the day, the problem is like we just don't know how many like business points you get from a given token. I don't know, is that the right way of thinking about this?
Yes, in some dimensions, and no in one critical dimension. So I had a whole bunch of reactions to this, and my first reaction is 100% token maxing is the wrong thing. And this token minting manifesto asserts that measuring outcomes is the most important thing, but it doesn't really explain how to do that. Just like you said, we can't really measure business value in any meaningful way. Every business measures its value in different ways. There are so many degrees of freedom between a given line of code, a given token, and actual monetary value or societal value or maintainability value or whatever value you want to call the output of that. So it's really hard to measure. Another interesting aspect of this, I read an adjacent article by Steve Yagi called The Flat Curve Society that was focusing, its initial premise was talking about how given Mythos class models, we're going to sort of see a flattening of capabilities because we're reaching the point where models won't be generally available to the public. And that's an interesting premise, but the follow-on from that was that the real work then becomes the educational journey of the majority. So right now we've been on this overall experience where everyone is pushing toward, like, we've got spiky capabilities. We've got like the people really running ahead in AI that can get 10x, 100x done. And then we've got a very large majority of people that are sort of working their way up that ladder of capability and understanding. And one of the things that Steve cited in his article was that up to the point of spending about 5 million tokens a day, token maxing actually is a decent predictor of overall output. But after that, and I think actually he said up to 15 million. After that, it becomes a really bad predictor of the overall quality of output. And that's where you get gamification of the metric. And so the idea of token minting, I think, becomes really important as the general populace reaches that level playing field of overall AI literacy, that everyone is now able to effectively use these tools. And now it's about effectively using them efficiently. So the last point on this one that really stuck out to me is that minting is obviously a very nice antonym to maxing, right? But I actually don't think it's quite the right metaphor for what needs to be done here. I think the real metaphor is efficiency. And there's a critical element that is missing from this Tokenminning manifesto, and that is that not all tokens are created equal. So the tokens that I can run on my laptop are, for all intents and purposes, free. I can use as many of those as I want. I can max the heck out of
Max
those
away.
ones. Exactly. The tokens that I spend on a very inexpensive model are less burdensome to my overall budget and to the environment, and all of the negatives that we have associated with the cost of a token, both monetary and environmental. So back to that initial point about Sakana Fugu, orchestration is going to play a key element here. And I think one of the big untapped areas here is this idea of local offloading. That happens to align with my personal interests because I love models that I can run locally. But truthfully, in my daily flow, I spend almost half the tokens I spend are on local models. Now, granted, I have some pretty nice hardware here in my house, so that's not accessible to everyone. But in the range of 30 to 100 billion parameter models, you can get a whole lot of work done. You can't get your most challenging frontier problems done. That's true. But you can get a huge amount of internet research, basic code implementation, exploration of your repository for, summarization and information dig. Like all of that stuff is not your frontier of capability, and you don't need an expensive frontier model for that. So that's where I think the story really needs to drive, is that efficiency of output, and that has both a use less and a use more inexpensive aspect to that overall equation.
Yeah, there's so many variables here. It's like almost like what tokens, where the tokens are.
It's a big,
I think
gorpy math equation. It's awfully hard to encapsulate that in a pithy phrase like token
like max,
so,
min.
Exactly.
Well, max under certain conditions, which you specify.
Yes, exactly,
exactly. Like yeah, exactly. Martin, I think one aspect, Gabe, you mentioned that kind of interesting like curve where it's like, okay, up to this many tokens, it's a good predictor. After this many tokens, it's a bad predictor. And it strikes me that that's actually a really interesting number because it almost reflects, Gabe, to your point, how efficiently people can use this technology. So you imagine a world where like everybody's using AI for the first time and they're just trying to like use it to figure out the problem. Like that predictor threshold is like way higher, right? Because the average person takes like just a lot longer to use the technology to solve the problem. But then over time, you actually want that number to slowly kind of go down because your hope is that people get better at using the technology. They can, they prompt better. And so they get the answer more quickly. And so your token consumption like decreases over time. I guess, Martin, just to turn this into a question a little bit, it's almost a little bit like, there's almost going to be like token deflation is what you want to see as people kind of get better and better because it's less about the tokens. It seems like it's actually more about the person, right? And how they use the technology.
Yeah, what this reminds me of is the laser printer at my first office. When I got my first job, they had this really fancy laser printer. It could print like 50 pages a minute or something. And we had full access to this thing. And we were encouraged anytime that we had like a PDF or manual or something that we wanted printed, just send it to this fancy printer and it would like spew this thing out in seconds. They had folders and you can put them in the ring binders.
So cool.
Yeah. And then at everybody's cubicle, they actually had shelves set aside so you could stack them up. You could basically make your own personal library. So that was print maxing. That was print maxing because who wouldn't want the biggest, fanciest looking library in their cubicle to show how busy and important and productive they were, right? Well, I left that company and I moved to a startup. And this was a tiny startup. There were 6 of us in one room above the harbor master's office at a marina. And I get there my first week and I come across this PDF with this Java manual. I'm like, oh, that might be useful at some point. So I send the job to the little laser printer we had in the office there. And within like 2 minutes, the founder is coming over to my desk and he's like, dude, we have a policy with printing here. You can print as much as you want, but you've got to read every word. And I'm just sat there looking across at the printer as it's spewing out page after page of this Java manual. And I'm like, I am at most going to read 3 pages of this. I just don't know which 3 pages, so I printed the whole thing. Printer minning, right? The fewer, the better. So I think that idea of just measuring productivity by I've printed this whole bunch of manuals, look how productive I am, or I've hardly printed anything, look how productive I am, is really the wrong metric. It's a very easy metric though to measure, right? I mean that's the thing, that tokens are a number. We can measure them, we can compare them against other people. But as Gabe and Tim, as you've both pointed out, a printer page is a printer page, but a token is, well, it could be a token from a model that's running locally on my laptop. It could be a pretty efficient token from a sort of small 100 billion parameter model, or it could be something from a frontier model that we are paying 50 cents for, every million tokens or something. So it could get real expensive real fast. So yeah, just the raw number is not a good measurement. But I still miss that laser printer. That thing was so fast.
Yeah, I think it's like you're revealing the absurdity of it, because like no one's like, bro, you got to be electricity maxing, or like you have to be, like why are you not water maxing? I think again that this is probably like the process of becoming more mature about how we manage and measure these technologies. A terrific discussion like always. Abraham, Martin, Gabe, thanks for joining us on the show today. And thanks to Huiming and Sascha for the special segment. That's all the time that we have. And thanks to joining all you listeners. If you enjoyed what you heard, you can get us on Apple Podcasts, Spotify, and podcast platforms everywhere. And we'll see you all next week on Mixture of Experts.